Arithmetic sequences. Arithmetic sequence is an order set of numbers in which each new term is obtained by adding a constant value to the previous term. Does this sound familiar? Let us investigate arithmetic sequence with the help of an example. A restaurant has rectangular tables which can seat 8 people. If we need to make one long rectangular table to seat more guests, the table must be placed next to each other, edge to edge. If we join another table, the total number of persons that can be seated becomes 8 plus 6 equals 14, because we lose 2 seats by joining the edges of the table. By joining 3 tables, we can seat 20 delegates. If we continue in this manner, we can see a sequence being formed. We can see that every table added gives us 6 more seats. This is nothing but a linear number pattern. The constant value that is added each time is called the common difference and is denoted by D. Let us plot the graph for an arithmetic sequence. The first term is 1, so we plot the point 1, 8. The second term is 14, so we plot the point 2, 14. Likewise, we can plot the other terms on the graph. As expected, the graph of an arithmetic sequence is a straight line. We can define an arithmetic sequence as a sequence in which the difference between any term and the term preceding it is constant. So, t2 minus t1 equals t3 minus t2 equals t4 minus t3. Recall that the general term of a linear pattern is given as Tn equals Pn plus Q, where P is the constant difference and Q is a constant. In this case, even if we know the first term of the pattern and the common difference P, we need to perform a few calculations to first determine Q and then write down the general term of the pattern. We will learn a shorter method of finding the nth term of an arithmetic sequence when we know the first term and the common difference of a sequence. Let us denote the first term of the sequence as A and the common difference as D. The first term, T1, is simply A. The second term, 14, can be rewritten as 8 plus 6. In terms of A and D, the second term will be A plus D. The third term, 20, can be rewritten as 8 plus 2 times 6. In terms of A and D, the third term becomes A plus 2D. Similarly, we can extend the pattern for the fourth term. Observe that when n is equal to 3, T3 equals A plus 2D. In other words, the third term is the sum of the first term and 1 less than 3 times the common difference. When n is equal to 4, T4 equals A plus 3D. In other words, the fourth term is the sum of the first term and 1 less than 4 times the common difference. Generalizing, we can say for the nth term, Tn equals A plus n minus 1 times D. This is a very useful formula to find any term of an arithmetic sequence, given A and D. Let us practice writing the general term of some more arithmetic sequences using this formula. Here, D equals 4 and A equals negative 5. Hence the general term for this sequence will be Tn equals 4n minus 9. We can verify this by substituting the value of n equals 1 to get the first term. Here, D equals negative 5 and A equals 12. Hence the general term for this sequence will be Tn equals 17 minus 5n.
Need more help? Subscribe to our channel. Can't wait that long? Ask Mesky to help you and let the math finally start mathing.